Hey, and welcome to this session of Excel. Today we're going to look more at functions and at how you can use certain functions and how specifically you can use the if function and some boolean logic. So we've looked at functions earlier, and we saw that in order to access functions you write equals and then you write the function name. For example, if you write sum, we get the function that takes the sum of several numbers, adds them together. And we then add two parentheses to indicate what we're gonna, what we're gonna put into our function. In this case, what we're gonna add together. When we start writing sum, we get a bunch of various different suggestions. And if we're not sure what the name of our function is, we can look it up by clicking this FX button, the insert function button. If we've written the function and we press this button, we get some information in an information box that pops up about the sum function, as we can see here. So we get some information, it adds all the numbers and arranges the cells, and then we get some information about the specific inputs here, and the name and so on, and get some preliminary results. If we have nothing and we just click this, then it adds an equal sign and we can add a function. We looked at some functions. We looked at sum. We looked at average, which takes the arithmetic average or arithmetic mean. That is, it adds all the numbers together and divides by the amount of numbers you have. So average, and then that's 1, 4, 6, 8. We take the average. These four, what is that? That's 4.75. That's the average of these four. We looked at the, so we can actually do them all here together. We can take the sum of these. We can take the average. We can take the minimum, which is just takes the smallest of these numbers, and the maximum, which is the largest of these numbers. And here we are. And if I'm wondering what it says here, I can go into the cell. I do so by pressing F2. I can copy this text, and if I just want the text here, for example, I can write an apostrophe and paste it in, and it will come as text instead. So apostrophe, and then we just paste the function in here. So I copy it, apostrophe, I paste it in, and we get it as text, as we saw earlier. So this is a bit of a warm-up. And if you don't want to click F2, we can also double-click to jump into what we've typed into the cell. So here we have, so this is what we've looked at. And there are a lot of functions in Excel, and there's not a need to know all of it. There's not a need to memorize every function. There are some functions that appear a lot of the time and are good to know, and there are other functions that are obscure and probably useless for most people, and there are some functions that are useful if you're doing a certain type of, if you're using Excel for a certain type of equations or models or modeling and that kind of stuff, but if you're not, then it's not that useful. So again, we want to be efficient with our Excel, so we want to use functions that we want to have a general idea of how to learn more about a specific function in case we want to use it, but we don't want to just memorize a bunch of functions if it turns out that they have no value for us. So we're going to look at a few more functions that are of interest. So one of these is the if function. And the if function is a very fundamental basic function that can help. It's a function that can be used in a lot of different ways. It has a lot of utility. So the if function basically does three things, and it has three inputs, as we see here. we write if, we get a suggestion of various kinds of functions that has if in them. And this is the if function, and then there's some, I think these are all variations of it, or specializations of it. Here we have the basic version, and the basic version of it has 3 inputs, as we see here, 1, 2, 3. And if we want more information, we click the FX here, we get a little box that can explain it. So we have 3 parts, and we see nicely if we click that, the FX, we get this box. It also completes the parentheses for us, and we can type stuff in here. It will add, fix them here for us. So it starts with a test, a logical test. What does logical test mean? It means we're applying a test that has a true or false answer. It's either correct or incorrect, usually in some sort of mathematical or logical expression. So we see here the description checks whether condition is met and returns one value of true and another is false. That's for the if function in general. And for the logical test is any value expression that can be evaluated to true or false. So we want to have any kind of expression that we get a yes or no or true or false answer to. And if it then, so it evaluates, Excel evaluates for us, is this true or not? And if it is true, it returns, gives us something. And if it's not true, if it's false, then it gives us something else. So that is the basis of this if function. It's a very simple function in a way, but it is very useful because you can build massively complex things with it if you want to. So for example, a logical test could be, is this, or whatever we have here in cell B8, is it bigger than what we have in cell C8? Now, obviously, these 2 cells are right now empty. So for that, Excel interprets them as having 0 as their value. And if it then evaluates that, well, 0 isn't bigger than 0. So this is false. We asked, is B8, is the sort of the value of B8 greater than the value of C8? Well, if they're both 0, B8 is not bigger than C8. So it's false. This is not true. So we get a preliminary sort of calculation here, or response. And then we say, okay, we should have a value of true. So we say, if it's true, it should give us 100. If it's not true, it should give us 0. And say, well, it's not true, it's false, so we're going to give you 0. Okay? And we see here that's what we get. But if we add something here, like a 2, then we get 100, because 2 is greater than 0. So we see that this function says, is this value bigger than that? If so, we get 100. If not, we get 0. So if we change this to 4, we see we're now at 0. Change this to 6, we're at 100. Now, that is a very simple way of using the if function. But we can type in different things. For example, we can say, instead of giving a response in a numerical way, we could give a text response. So we could say it's either fine or there's a problem. For example, if this always should be bigger than that, well, if it is, then it's fine. Otherwise, there's a problem. We'll see if there's any problems. We see what happens if we press enter here. We get a name. Why do we get name? And what is this? Well, we looked at this a little bit, and there are various errors in Excel where Excel doesn't know what to do. And then it gives us an error code. And those are shown as hashtags. So here we see it says hashtag. Now that's an error. And this is name question mark. Now that means that we're referring to something that Excel doesn't know what it is. It says this is something, it's a name, you're referring to something, but I'm not sure what that is. And that's because we've written fine here and problem here. Now, for example, if we named a cell, remember we could name cells up here in the name box. If we'd named a cell, fine or problem or something else, Excel would think, okay, if this is true, then return whatever contents you have in cell fine, and if not, return whatever the value is of cell problem. So that could be a potential way to deal with it, but it doesn't have those names recorded. We haven't named any cells fine and problem. So it is unsure, and that's why we get the error. So what is the problem here? Well, the problem is we want it to return the text. So in order to do so, we need to add quotation marks. So we do that, and that's how Excel understands, okay, you want to just show us what's inside these quotation marks. So then we get fine here, because 6 is bigger than 4. If we get 2 instead, we get problem. This is nicely done automatically. Let's remove this and go into our text box here. So if we have this and we can just write fine here and problem. If we write it into our text box, then Excel will automatically add the quotation marks. You see, I wrote just fine and problem, but Excel added those. So we now have something that can evaluate. And oftentimes what we want is perhaps have a text, or perhaps have, if it's fine, that's okay, that's great. We want to find when there's a problem. So we don't really want to say fine or problem, because if we have a lot of different values, then you just get a big load of, looks like this. And we might not like this. We might not, it gets cluttered. So we might just want to be able to quickly see if there's a problem. And Excel can do that. So we see here's the, we see there's a problem. But if we just delete this one, we might see there's a problem. But there's an easier way to see if there's a problem. And that's just remove this. And that's a solution to it. And just keep the 2 quotation marks. What will happen then? Well, that means we get nothing if it's fine, and we get the text problem if it's not. So, and now we can see it much easier. We can see where the issue lies, or where we have a problem. So that is one way of adding, either we add numbers, or we add text, or we add just nothing in here. But there might be another issue. I'm going to just hold this down. So for example, we might want to test, as we do here, whether this is bigger than that. And sometimes you have, and oftentimes there are these simple questions of, I just want to see if this is bigger than that, or if this is compared to that. For example, are they equal is another thing we could check, or, other relationships, just any kind of yes-no question. But sometimes it isn't a yes-no question we have something more complex, like is it bigger than that or bigger than another thing. So for example, if it's fine if B is bigger than C, but if B is smaller than C, it can also be okay as long as A is bigger than C. So either A or B need to be bigger than C. One of them needs to be bigger than C for it to be okay. For example, if we go with the assignment, we have register 1, and we have register 2, and we have sort of payments or something. So as long as we have enough cash in one of our registers, I mean, obviously probably would be in both of our registers combined, but let's say these are in different areas or something. As long as there's enough cash in one of the registers to deal with an individual payment, that's okay. That could be a scenario we're in. The issue here is that that's not a simple yes/no, but it can be dealt with by adding 2 yes/no questions. So is this bigger than that? Yes or no? If the answer is no, then we might have a problem. Then we do a second check and see if this is bigger than that, right? So we see if, so we can start with register 1. Is register 1 bigger than the payment? No. Okay. Then we see register 2. Is it bigger than payment? Yes. And in that case, we're fine. So we're doing 2 steps. And you can do this in your if. And it's by saying by doing it this way. Either we start here. Oops. Register 1 is bigger than our payments, which is C8. And if that's the case, we're not going to write everything. Everything is okay. We just want it to be blank. But if it's not the case, do we have a problem? Maybe, but not necessarily. Not if we have enough money in register 2, so we have to check that. We can add a second if. So we can add an if function as an input into our if function. So write if this is false. If this is big enough, then that's fine. We return this. But if it's false, we do another check. So we check if this one, B8, is bigger than C8. And here, we might have a bit of a problem. Not necessarily, but we might not want to write it in this box. So we can just, I don't know, do something like this, where we finish it off or something like that. But we see if we're in here, we see that we have this if case. That's an outer case. We check first this condition, and if that's true, we're fine. But if it's false, we go into a new if case. And if we click here, and we click, then we get into our box here. But if we click, that's if we're selected somewhere within this if function. But if we click within the second one, then we get the box for that one, and we can use that logical test. So what if that is true? Well, if that's true, if register 2 is bigger than our cost, then we're also fine. Otherwise, there is a problem. So now we have we can just write problem. It will add the quotation marks. So now we have a what's called a nested if function, or nested if functions, or if statements. That is, we try one thing. If that fails, we try something else. So it's you can think of it as a branch. You ask one question, and then that leads to a follow-up question to a follow-up question. And potentially we could do as many as these as we wanted and do quite complex models. Now we don't want to do too complex models and too many nested if cases, because Excel can be quite difficult to get an overview of. It might be better off to solve it in a different way. But it's good to know if we want to ask just a little bit more complicated questions than a simple yes/no. If there's other kind of contingencies, we can add an if statement into our if statement. So we see here that it's not a problem, except for here, right? So in all these cases, we have enough. It's not a problem at all. But here, where we have less than in both register 1 and in register 2, then we get a problem. So that's our if case. It tests both. Now, we can use that for if cases, but in fact, we can use that for anything really, as in we can always put a function into another function. We might remember from algebra that, we could have functions that looked something like this. You have a function inside of a function. And what you did was you just took and sort of put the one function as an as an input. The output of the inner function became an input in the outer function. So the output of g of x became the input of f of x. And we can do that in Excel as well. For example, we can take the as we saw, we can, and I think it's easiest if we do another if case. We can, for example, say if, and as a logical test, we can just say, okay, we'll take the minimum of these 4, or we might take the sum of these 2 registers, and the sum of those 2 registers has to be bigger than the payments, otherwise we're in trouble. And if that's true, then we're fine. Otherwise, we have a problem. And we see here, in this case, 7 plus 5, we have enough cash to make our payments, so this becomes empty. But as I drag this down, we see we have a problem here where we don't have enough cash. But here, for example, as well, we would, if we do something like this and like that, here we'd have a problem because we don't have enough cash in either single register. But if we can use both of them, we don't have a problem in this one. So, and as it looks like in text, it just is one function inside another. And that's a way to sort of add functions into functions. Now, if we want to use functions, we have to put an equal sign in the beginning, but we don't have to put one here. So sometimes people think, oh, we should write something like that. No, we just put an equal sign at the start, and then we can write off the functions as we want to. So I talked a little bit about Boolean logic, and we can look a little bit into that. Boolean logic is just the basics of having yes or no statement, logical statements, and it's a very simplistic sort of way of sort of characterizing all statements in simple true or not true. So you can have, and it's either so things are either true or they're false, and usually that's represented as a 1 or a 0. So that's why it's very useful in computing, because computing uses 1s and 0s to apply Boolean logic. The guy who figured that out, he was quite smart. His name was Claude Shannon. You can look him up. But the fact that we then can apply Boolean logic to make it into 1s and 0s allows us to be able to use computers and the 1s and 0s in computers to produce sort of any kind of logical system based on that. So Boolean logic exists within Excel. For example, if you ask certain kinds of questions, Excel will answer in a true or false manner. So it will give you a Boolean logic answer. For example, we can say, is this bigger than that? Then we get an answer here. We get a true. We can check down here. We see here it's false. It's not bigger. They're the same size. And same here, it's not bigger. It is smaller. So we see we get an answer. In a similar way, we can write, are they the same? Then we get false. But here we get true because here they are the same. So Excel has a built-in Boolean system, and it's quite useful to know about, especially if we're creating these if functions as well. If we want to use the if function, we can use that Boolean system as well for it. It will create a false or not. So we can always test that. We saw a preview here where it says false, but we can test this by just typing this into a different cell, and we'll see what result we'll get in this. So our if function uses Boolean logic, and we can apply it as well. Let's see. So that is a little bit about functions. There are some discrepancies and some issues that can appear, and that has to do with Excel counting things. We saw earlier that there's a precision issue. There's also an issue where we have numbers that are, because of the way Excel works in a binary system of 1s and 0s, it changes the representation of numbers, which might, in practice, be that even though we get the same representation and it shows us the same thing, there might actually be a small rounding error if we do some calculations that we think shouldn't be the case, because we, when we calculate things or when we read it, we deduce it based on our mathematical ability algebraically. But Excel, as a computer, doesn't work algebraically in the same way. Instead, they basically just count things out and do things numerically and not necessarily using the sort of same kind of time-saving ways we do it, so we might see it holistically. So let's look at one of those examples. For example, we can write 1 divided by 1,000. Okay, that's 0.001. And we can write 1 divided by 1,000 plus 1 minus 1. Now, in our minds, when we see this, we say, well, plus 1 minus 1, that's just 0. So we just get back what we started with, this. And we see that's the representation we get. And we see that these two are the same. So even though I've written this extra stuff here, we get the right answer, as we can see up here as well. Different things, but the same output. But now if I write is that equal to that? We get false. They're not the same. And that has to do with the calculations that Excel does. We see if I instead write +0 here, it becomes true because 0 doesn't affect the number. So it doesn't get this kind of rounding error that it gets here. So these are not exactly the same in the way Excel converts it to binary code. So it doesn't have to do with the fact that we've written different things in here. Here we've written 1 divided by 1,000. Here we've written 1 divided by 1,000 plus 0. Those are two different things we've written. It doesn't compare what we've put in, but it compares output, what comes out. And that is the same here, but because of a rounding error, if we write 1 plus 1 minus 1, we get false here, even though they are supposed to be the same. You can see if we can even see that. I don't think we can. So again, this is actually we can. See, here we get the rounding error in the precision of it. So we see that there's a small rounding error here based on how it makes the calculation. So instead of saving time as we do and just say, well, these two take each other, cancel out, let's just remove them, not think about them, let's just look at this, it actually does the calculations and gets a small rounding error. Okay, so that's a small introduction to, a further introduction to functions and some of the functions that we've looked at, especially if functions.